Okay, we're almost finished with section 4.1. Rewrite the following as algebraic expressions of x and state the domains. We're going to start here. If we're finding the arc cosine of x, what we're saying is that the cosine of some angle theta is x. So if we want that to be like an adjacent over hypotenuse, we would put that over 1. All right, let's go ahead and draw a picture. Just going to put it in quadrant 1 because this is just a generic case situation. So here's my triangle, here's my angle, adjacent is x, hypotenuse is 1. Okay, let's look at what we're trying to find. So we're trying to find tangent. If it had just been cosine, then of course the answer would be x, and we'd be done. But since it's tangent, we're going to want the opposite side too, so that we can do the tangent of this angle theta is opposite over adjacent, right? So let's go ahead and find the opposite side. To do that, we're going to use Pythagorean theorem, so a squared plus b squared equals c squared. So going backwards, we would do 1 squared, which is 1, minus x squared, right? So there's the opposite side written as an expression. So that if we were to do x squared plus the square root of 1 minus x squared and combine that together, we should get 1, right? Using Pythagorean theorem and going the other direction. Okay, let's go ahead and do our opposite over adjacent. So that would be the square root of 1 minus x squared over x, and I don't think we can simplify that at all. So let's go ahead and leave that as our answer. The last step of this is to state the domain. The only domain we need to be wary of here is, well, there's two things we have to pay attention to. So the first one is the domain of the arc cosine, because all we can do is plug in values of ratios that will work for inverse cosine, right? So that's between -1 and 1. So for our cosine domain, let's try this, it would be from -1 to 1. But then when we plug that into tangent, we now have to pay attention to the tangent domain. And the main issue there is that if we plug in 0 for x, and this is of course in terms of x, what's going to happen to this problem if we plug in 0? So if we plug in 0, if x equals 0, this is undefined, right? Must hit on one of those asymptotes or something. Okay, so in other words, the domain cannot be from -1 to 1. That's just for the inverse cosine. So the overall domain for this problem has to also include that we can't divide by 0. So that's going to be from -1 to 0, and then 1, or wait, 0, 0 to 1. That's supposed to just be a parenthesis, it's rather more like what we're going to be using very soon for things like vectors. So just want to make sure that's rounded. Domain from -1 to 0 and 0 to 1, not including 0. Okay, example 5. Rewrite the following as an algebraic expression of x and state the domain. I was trying to figure out if the grammar was wrong there, but I guess it works. Okay, so again, we're going to start with this part. We're going to say that the arc sine of x equals theta because sine of theta equals x, and that means it would be x over 1. Opposite of hypotenuse, basically, right? If we decide we need a picture. I'm not sure yet if we actually need it. So that means we can actually replace this arc sine part of this with just our angle theta. So that turns us into the cosine of 2, and then arc sine x is theta, so cosine 2 theta. Oh, well that's interesting. Instead of just finding a cosine or a tangent or a sine, we're finding the cosine of 2 theta. That might mean we want to use one of our cosine double angle identities. So we have 3 different ones we can choose from. We have one that has both cosine and sine. We have one that has just cosine, and we have one that just has sine. Well, the one with just sine is obviously going to be the most convenient, because then we already know that sine is x. We wouldn't have to do anything else. So let's go ahead and choose one of our identities. We're going to choose the one with just sine, so that is 1 minus sine 2 sine squared. Right? The other two options are cosine squared theta minus sine squared theta, but then we would have to find cosine, which isn't that hard because we used, you know, we can use identities or picture or Pythagorean theorem to find that other side and find the adjacent side and find the cosine. So we could do that formula. Or we could do the formula that's just cosine, but then we would definitely, again, have to find the cosine value. So it just makes sense to me to just use the sine for this one. So that means sine is x. We're just going to square that. And we've got it. It's just 1 minus 2x squared. That is an expression for the value of cosine 2 theta if sine is simply x. Okay. All right. What's the domain going to be? Sorry, yawning. So again, we have that inverse function domain from -1 to 1, which we can plug in for x. And then I don't think there's anything that's going to mess with this to make it undefined anywhere or cause us any other issues. So I think our domain can just stick with that original domain for the inverse sine function. And we're done. Something that I wanted to look at that might be interesting is, would this formula work? You know, we could try either one of them. I'm just going to play around with this one. Would this formula work if we knew a cosine and we wanted to find the tangent? So this is just for my own curiosity's sake, not something you have to do. But I feel like we created this formula so that if we know the value of the cosine, we can find the tangent. Doesn't that seem like it would be? So let's pick an angle, like cosine of 60 or something. So I'm going to do 60 degrees. So we know the tangent of 60 degrees is square root of 3. So that's just going to hang out here, and that's just going to be our guideline. So let's use our formula we just created. 1 minus the cosine of 60 degrees, which is 1/2. Oh, and that square root, I made it too big because the square root is only in the numerator. So square root of 1 minus 1/2 squared all over 1/2. So that would be the square root of 1/2 squared would be 1/4, right? So let's get a common denominator. 4/4 minus 1/4 over 1/2. So that would be 3/4 over 1/2, which would be the square root of 3 over 2 divided by 1/2. So I'm going to turn that over and multiply instead. And then those cancel out. And our answer is square root of 3. So that worked. If we've just created an expression or an identity, I guess, or formula that we could use if we know the cosine of an angle to help us find the tangent of an angle without needing to know the sine. Pretty cool.